Hey, so today we're going to look at an easy LeetCode problem number 217, contains duplicate. And we're going to have a quick read through the problem description, and then I'm going to show you 3 different ways of how you can solve this problem. So we're given an integer array nums, and we should return true if any value in that array appears at least twice. And we should return false if we don't find any duplicates. As usual, let's have a look at the constraints first. We see that the number of elements in the array is at most 10 to the 5, and the value of those numbers is between minus 10 to the 9 to plus 10 to the 9. All right, so the easiest thing to do, I think, is we could simply use, we could simply turn the array into a set and then compare if the length of the array is equal to the length of the set. So that would look like this. So we take the length of the array and we compare that to the length of the set that we would get from the array, right? And this is obviously O of n time. And also O of n space, because we need the space to build the set. So this is really quick, and we're using Python's functionality to create a set quickly from an array of numbers. And if we run this, we will see that it actually works quite well. So another way that we could deal with this is we could instead use, we could iterate through the array and then check if we've seen any of the numbers that we're iterating through, if we have seen any of those numbers before. So that would be the second approach. And now we are still going to have O of n time in space, but we don't have to iterate through potentially we don't have to iterate through the whole array of nums to actually find a duplicate. In the solution here below, we have to basically iterate over all of the numbers to create the set, which in this solution we might not have. So what we'll do is we use a hash set, and then we just iterate through all of the numbers, and then we check if n is seen, then we return true, and otherwise we return false. Now, we also have to add, of course, the number n to our set. So if we run this, it should also work. Right. And when you implement this, you can submit it to see that it works in all the cases. I'm just not going to do this right now. Now, another approach would be, and this is something that comes up in interviews as well. You know, why did you choose a certain implementation? Why did you choose an O of n time and O of n space algorithm over maybe another one that only uses constant space? So as an alternative, you could offer a solution that uses O of n, n times n, so n squared time, and constant space. This is, I guess, the brute force approach that you could come up with first. But after doing some LeetCode, you know, the other solutions are probably more natural to you. So in this case, we just iterate over the array nums, but with 2 loops. So we iterate with an index I, and then we iterate over an index j. And we start at the position I plus 1 to the length to the end of the array. And now we simply check, is the number at position I the same as the number at position j? So we do a pairwise comparison between all of the numbers individually. And the benefit is that we don't have to store anything, so we have constant space. But the drawback is we now increased our runtime from O of n to O of n squared. So if nums I, nums j, then we return true, we found a duplicate. Otherwise we return false. And that's pretty much it. So, I made a mistake. J in range num is not defined, so nums. Right, there we go. So yeah, I have not seen a lot of discussion about the space complexity in a lot of interviews. Usually they only focus on the runtime, but being able to explain the trade-offs in terms of space and time complexity is a good practice that you should probably be able to do. In an interview, you would probably come up with this solution. A solution like this is, I mean, it's like, what do you call this? Golf code. Or coding golf, where you just try to find the shortest way possible to do it. So yeah, have fun with this. I just wanted to show this real quick. There's nothing really deep about this, but if you're just starting out with LeetCode, you know, try to implement those yourself. Maybe submit them as well to see how their runtime is different. You should clearly see that this one is the slowest. You will probably also see that this one is slower than the last one, simply because this one used Python built-in functions, which of course implemented in C or something similar, whereas here we use Python to iterate through the numbers, which is probably slow as well. But that doesn't matter for the runtime complexity. The first and the second solution, they're equivalent in terms of space and time complexity. And then we have the last one. That's pretty much it.